Hello, good people. I hope all is well with you. This is Mr. Lowe with the recording for lesson 5.3 in our unit on sequences. Today we're going to look at geometric sequences. So we've already spent time with basics of sequences and with arithmetic sequences. So today we're going to focus our attention on a geometric sequence. So just to recap, arithmetic sequences focus on adding and subtracting. So if you're given an arithmetic sequence, the first number is your first term. The numbers that they're either increasing or decreasing by, that is your common difference. So in section 5.2, we examine how to write the equations for them and solving it using word problems. Today, we're going to look at the other side of that coin, which are geometric sequences. So arithmetic focuses on adding and subtracting. So you probably guessed it. Geometric focuses on multiplying or dividing. Again, by the same number. Still has to be by the same number. So the number that is being multiplied or divided this time is known as the common ratio. Common ratio. So ratio R, so the letter that we're using is R. So just like last time, we're going to start out by doing some basic identification. Identifying first term and identifying the common ratio. So in our first sequence of numbers, first term, again, is the number that leads off the sequence. Now, to get the common ratio, sometimes the common ratio is pretty easy to identify. To go from 4 to 12, you're multiplying times 3. 12 to 36, multiplying times 3. 36 to 108, multiplying times 3. However, there is a way for you to calculate this. There is a way for you to calculate this pretty simply. So to get the ratio, you take the second term divided by the first term. And this will work all the time. So second term divided by the first term, so that's 12 divided by 4, which is 3. So your common ratio here is 3. So again, the reason why I show you a formulaic approach to it is because not every single ratio is going to be simple to figure out. Case in point, example 2. So example 2, 400, 360, 324, etc. So we can identify the first term real easy. That's 400. But common ratio, I'm pretty sure most people off the top of their head are not going to know 400 times what is going to give you 360. So to figure that out, to get that common ratio, you take the second term divided by the first. So 360 divided by 400. So we let the calculator do a little bit of work. 360 divided by 400 should give you 0.9. So in this case, you get 0.9. So yes, you can get decimals as your common ratio. You can get negative numbers as well if it was toggling back and forth, negative and positive. So things to keep in mind as you're going along. So first term, to get the ratio, take the second term divided by the first term. Second term divided by the first term. So just like last time, we need to know basics in order to be able to write an equation. But I can guarantee you, writing these equations are a lot simpler than arithmetic. At least the work is not as intensive. So, formula that we use. So we have a new formula. A sub n equals a1 r to the n minus 1 power. So this is the same thing as a1, first term, times r to the n minus 1 power. So a1 is still the first term, r is the common ratio, n is your desired term, and a sub n is the value of the desired term. So just like with arithmetic sequences, once you write the formula, then you can use it to find any number that you need, as opposed to listing out all the numbers until you get to where you want to be. So, example 1, we're taking the sequence right from the top. 4, 12, 36, 108, etc. So we know that the first term, A1, was 4, and the common ratio was 3. So that's step 1. Step 2, take the first term, plug it in for A1, and take the R value and plug it in for R. So A sub n equals 4 times 3 to the n minus 1 power. Now, with step 2, with a geometric sequence, that's it. There's nothing else to do to write this equation. That is solved. That is solved the way it is. Please, please, please do not take the A1 and the R values and multiply them together. That is the most common mistake. The most common mistake people make is taking the 4 and the 3, multiplying it together, and making it 12. Absolutely not. Absolutely not. Number 1, that's a violation of the order of operations. If you were going to solve that out, then you would have to have done the exponents first and then multiply. So that's a direct violation of the order of operations. Once you plug in A1 and once you plug in R, that is it. You're finished. And then once you get your formula, you want A10. So A10 is n equals 10. So 4 times 3 to the 10 minus 1 power. So 4 times 3 to the 9th power. Now do keep in mind, these numbers are going to get big. Have the potential of getting big. 3 to the 9th power, because you follow order of operations, is 19,683. And then you multiply it times 4. So 78,732. So just know this in advance. These numbers, in many cases, are going to get huge. They're going to get huge. All right, so that's how we write. That's the 3 steps. Identify the first term in the common ratio. Substitute the values in to simplify it. And then find whatever value they ask you to find. Very simple process. Very simple process. So, with that, let's work on example 2. Same rules apply. Same rules apply. We're going to write the equation and then find the 10th term of the sequence. So, all things being equal, we follow the exact same steps. So, step 1, identify A1 and the common ratio. So, first term, that's easy. 400. To get the R value, that's second term divided by first term, which we did this one already. Ends up being 0.9. So that's step one. Step two is to write the formula. Write the formula. So there's the basic formula. So A sub n equals 400 times 0.9 raised to the n minus 1 power, which, once again, that's it. There's no other simplifying necessary. There's no other simplifying necessary after you do that step. So no other simplifying necessary after you do that step. So step 3 is to find the desired value. So the desired value here was A10. So n equals 10. So 400 times 0.9 raised to the 10 minus 1 power. So 10 minus 1, of course, is 9. Let the calculator do a little bit of work. So you have 400 times 0.387 and a whole bunch of numbers. So I'm not going to write all the numbers for the sake of time. But in your calculator, you can literally take the decimal answer that you got, multiply it times 400, and you get 154.968, so 154.97. Again, I rounded to 2 decimal places because I'm always in the mode of thinking about money, and money goes to 2 decimal places. But as you can see, that's same operating procedure, same exact operating procedure. Identify A1 and your R value, write the formula, find the desired value. It's simple as that. Do not make it harder than what it is. You don't need to make it harder than what it is. Step 3. So example 3. Example 3, same type of problem. So now we should be able to go through this one pretty quickly. A1 is your first term, 1/2. R value is your second number divided by your first number. -2 divided by 1/2, which gives you -4. So remember, if you're putting it in the calculator, put the fraction in parentheses or simply change it to 0.5. One or the other. So there's your A1, there's your R. So when you write your formula, you have -2 times, actually take that back, sorry, 1/2 times -4 raised to the n minus 1 power. Remember, we don't multiply the 2 numbers together. We leave them as is. So there's step 1. There's step 2. So step 3, find your desired value. So A10 is equal to 1/2 times -4 raised to the 10 minus 1. So now you're just doing some basic solving. -4 raised to the 9th power is -262,144. So -131,072. Again, remember, these numbers have the potential of getting very big very quickly. Getting very big very quickly. So be careful. Be careful. So we've done some basic examples. Let's work a couple of applications. So New clothing store launched a website. 158 visitors Monday, 316 on Tuesday, 632 on Wednesday, so on and so forth. Write a rule for the number of visitors, if n is the number of days, and then find the number of visitors after 7 days. So first you read the problem. You'll see that there's 158 on Monday, followed by 316 on Tuesday, and 632 on Wednesday, so on and so forth. So if you write out the problem, then you have that your first term is 158, and your R value is 316 divided by 158, 2. 2. So in other words, that means you're multiplying by 2. It's doubling each time. So there's step 1, though. So a sub n, a1 times r to the n minus 1 power. So write your formula. So there's your formula. And after that, they want to know how many visitors after 7 days. So 7 days, translation, n is equal to 7. Why? They told you that n was equal to the number of days. Told you that n was equal to the number of days, so there you go. So A7 is 158 times 2 raised to the 7 minus 1 power. So 2 to the 6th power. 2 to the 6th power is 64. So after 7 days, this particular website has 10,112 visitors. So not bad. Progressing. It's a progressing clothing website. So hopefully they do well in their sales. So there it is, and there you go. It's the same 3-step process. It's just put in an application. It's the same 3-step process. So there's nothing to freak out and get worried about. So, last but not least, example 5. Colin's first full-time job paycheck is $1,700. He immediately gets to spending the paycheck. After 1 day, he has $1,530 remaining. 2 days, $1,377. If the amount Colin has left follows a geometric sequence, write a rule for the amount of paycheck left in the bank, and find the balance after 14 days. So, as you can see, he's starting with a particular amount, and then it's decreasing each time out. Decreasing each time out. So if we're following a geometric sequence, so his first term is 1,700. His R value, 1,530 over 1,700. So again, this time it's not a simple number to figure out, but we have a way around it. So it's 0.9. So we've got 0.9. We've got our A1, we've got our R. So in other words, from a real world standpoint, that means Colin has 90% of his paycheck or 90% of the money that's in his bank after each day. So he's spending 10% of his money. So let's plug in what we have. 1,700 times 0.9 times n minus 1. So we use our formula to calculate 14 days. So A14 represents 14 days. So on the 14th day, how much is still in his accounts? So 1700 times 0.9 raised to the 14 minus 1 power. So again, decimals get a little funny. So 0.9 raised to the 13th power. Remember, you do your exponents first. This is order of operations. So you get 0.254 and a whole bunch of numbers after that. So if you're working with a graphing calculator or a scientific calculator, just use all the numbers in the calculator. Take that answer, multiply it times 1700, and after 14 days, Colin has in his bank account $432.12. So, why was 14 days chosen? Because chances are after 14 days, he's probably getting another paycheck. He's probably getting another paycheck at that point. So, other than that, that's it. As you can see, geometric is a little bit more user-friendly. Trade-off, your numbers could get pretty big pretty quickly. Get pretty big pretty quickly. But the steps are still the same. Identify first term common ratio, substitute into the formula, and then solve it on out. So now we've worked with both arithmetic and geometric sequences. We've worked with both arithmetic and geometric sequences. So just to give a final differentiation between the two. So if you have a arithmetic sequence, so arithmetic means you're either adding or subtracting. Adding and subtracting, so let's do 16, 11, 6, 1, etc. So A1 is your first term. So to get your common difference, you take your second term minus your first term, which in this case would be 11 minus 16, negative 5. And then to write your equation, that's an equals a1 plus d to the n minus 1 power. Take your a1, take your d value, plug it into the problem, and then you simplify it out. So it becomes nothing more than an algebra problem. Becomes nothing more than an algebra problem. Contrast, geometric means something is being multiplied or divided. Something's being multiplied or divided. So if we go ahead and take a look at this type of problem, so let's do 640, 160, 40, 10, etc. First term, 640. This time you need a R value if it's a geometric sequence, so that's second term divided by first term. So 160 divided by 640, so that's 0.25. That's 0.25. So yes, it can be a decimal. You'll live. So once you have your first term and once you have your common ratio, now you've got your formula that you can use. So 640 times 0.25 raised to the n minus 1 power. And then this time, there is no simplifying for that. That is your answer, point blank and period. That's your final answer, and that's that. So there's the difference between the two. Arithmetic, use adding or subtracting. Geometric, use multiplying or dividing. They've got their own setups and formulas for it. So again, if you take the time and you practice it the right way, you'll be in excellent shape. With that being said, please feel free to utilize the notes as you need to. I hope this is useful to you. Have a great day, and I'll talk to you soon.